Remember the cat food dataset we explored last time? We've cleaned it up and discovered some interesting trends, but now it's time to level up. Let's see if ChatGPT can help us build a machine learning model. First things first, what's your goal? Every classification task starts with a question, what do you want? This will help you and ChatGPT stay focused. The goal is to create a system that predicts whether a product is tasty based on its star rating. So I'm asking ChatGPT. No, it doesn't work that way. Don't overwhelm ChatGPT with one big question. Instead, break it down. Start with pre-processing. Then split the data. Choose a classifier. Next, train the model. Evaluate it. And finally, you can optimize the model. Simple step-by-step prompts work wonders. Let's try this. Good. The chat options for encoding the data are Pandas or Scikit-learn. Pandas is the simplest approach, so let's choose it. But since we only have 8 companies with 10 and more products, let's only consider them. Otherwise, we would have 41 more features. That's too many for the amount of data we have. Next, I need a binary target column for classification. I asked ChatGPT. Good. The yummy column is ready. Let's check if the classes are balanced. Turns out I've got 57 good and 64 bad. Close enough. By the way, classifiers do better with comparable features that vary in the same range as the target column. I asked ChatGPT and now I'm following the steps it offered, importing the required libraries, selecting the features to scale, and the scaling method. I chose normalization to put all my data in the same range as the target column. So we are ready for classifiers. I'm asking ChatGPT. It provides a code for the naive Bayes model. The code works, but the model accuracy is low, and the confusion matrix shows it struggles with bad food recognizing only 4 correctly. Probably other models will perform better. Prompt design isn't one and done. Let's look at ChatGPT's recommendations and in addition to the probabilistic naive Bayes model, test linear models such as logistic regression and support vector machines, tree-based model, and instance-based model, k-nearest neighbors. Let's use the code created by ChatGPT to compare the models. Logistic regression works better especially with the bad stuff, but fails a lot with the yummies. The accuracy of k-nearest neighbors is even higher. With the same detection power for yummies, it handles 1 more of the bad ones. Decision tree is the worst with an accuracy of 64%. This model seems to be overfitting. We have too little data for the model complexity. But SVM is the best with an accuracy of 88%. It was wrong in only 3 cases of bad food recognition. Clearly, SVM is our winner. However, I like DT also because it allows to explain how the decision is made. So what did we learn? A good prompt makes all the difference. State your goal clearly. Provide context and ask for step-by-step instructions. Test, refine, and compare results, and yes, some understanding of machine learning theory would really help. ChatGPT isn't magic, but with the right prompts, it's like having a data scientist on your team. And there you have it, from data to classifier in minutes. See you in the next video. Keep creating and keep learning.